Hi, my name is Abhijit and I'll be presenting on my project which is titled as System Theoretic Approach to Improve Robustness of Learning Algorithm. So the motivation of the project goes to exploring if we can use system theoretic approaches, especially those in the control theory, to improve the learning algorithm. Um, Now, what I'm trying to do here is basically bring back some control theory concepts and apply it in the data sets to see if I can recover some of the robustness that the supervised learning algorithm would otherwise fail to detect. So for example, in my project, I've been using this occupancy data set from the UCI webpage, which basically has a bunch of features like CO2 level, light intensity, humidity, and humidity ratio, and then those features get used by the author to detect whether a room is occupied or not. Now the room occupancy has been done on based on a video image, and it's manually generated. But instead of doing so, I wanted to see if I can achieve good accuracy using just only one sensor, and it's partly driven by my company's motivation, which is Carrier. They're trying to see if only one sensor we can get away with only one sensor. So the main approach here is basically I go through the data set, training data set, and do an offline training of those training data set in a ODE format. So whether there is occupancy equals to 0 or occupancy equals to 1. So I have two different models which describes the temporal dynamics of the CO2 levels, and then I compare that with the real-time estimate of the CO2 measurement, and those error, or the residuals as I call it, gets weighted by the covariance or the variance of the sensor noises. And then there's a simple thresholding that I can do to figure out whether the room is occupied or not. And now here this plot shows the results of the test set, and this is just the CO2 level, and this is where I'm plotting D0 and D1, which is this weighted residuals, and the black, the third spot here is basically just the data set, the actual level, and the actual results you can see it here, where the same test data set, the actual level, and the LDS, so the linear discriminant analysis, which recovers like 78% of accuracy. um, Most it predicts pretty well for when the room is not occupied, but doesn't really do well when the room is occupied. And here's where my proposed algorithm works, where it does a pretty good job of when the room is occupied, and it's basically doing it by virtue of the fact that there's a good model of how the CO2 dynamics play in when the room is occupied or not. Now the future step would be to sort of see if we can fuse this LDA and this approach to get even more accuracy. In my algorithm, the accuracy I achieved was 82%. So I'd be looking into if we can improve this even further. Thank you.